All right, so now today we're going to be talking about angles and polygons. Now these can be really difficult for students, so just make sure you're really paying attention and pausing it if you don't understand. Then other students find these really fun too, so hopefully it'll be on the fun side of things. But go ahead and pause the video and try the warm up, and then we'll go over it. All right, so it says, which of the following is not an appropriate name for the angle shown? All right, so we know angle Q is an obvious one. Angle PQR, angle RQP. So those are three different ways. So this one over here that does not have the Q in the middle will be the one that we cannot use to name it. All right, classify the angle shown. So looking at this angle, it's greater than 90 degrees, so it is obtuse. All right, and then same thing here. We're gonna do what we learned in the last class or last lesson, where we add our two inside angles together, 2x plus 65, that are not adjacent to this one, and set it equal to the one on the outside, so 3x plus 25. All right, we'll subtract 2x, subtract 25. We get 40 is equal to x. We're done. Oh wait, are we done? No. Okay, so we're not done yet, okay? So we have to find the measure of PQS. We gotta plug that 40 back in. So 3 times 40 plus 25 will give me, this is 120. 120 plus 25 is 145 degrees. So we have now answered the question. So be careful with these. This might be a test question. So just be careful that you read what it's asking. It's not just asking for X, it's asking for PQS. Here we go. So we're going to talk about polygons versus not polygons. And so polygons basically are anything that have lines that connect to each other. So all of these are examples of polygons. Some examples of non-polygons would be just a one-dimensional shape where you just have lines, or something with curves. We're not talking about curves when we're talking about polygons. So here's some of the names of polygons that you're gonna have to know. Triangle is 3, quadrilateral is 4, pentagon is 5, hexagon is 6, heptagon 7, octagon 8, nonagon is 9, decagon is 10, dodecagon is 12. I like dodecagon, it's pretty fun. And then after dodecagon, you just put 13gon, 14gon, so forth and so on. So they kind of got tired of making up names, and they just decided, oh, we're just going to say whatever number it is and then gone after that. So you must memorize these. So put a star by them and say memorize. So you make flashcards, make something. This is what makes geometry different, is that there's some memorization involved, and instead of like algebra where you memorize a procedure, here you have to know some definitions as well. Okay. So here is the biggest thing that you must remember when it comes to finding angles and polygons. And it's this formula right here, okay? We know triangles are 180, but for any kind of polygon, we can find the interior sum by taking however many. So for example, triangle, we did 3 minus 2, which is 1. 1 times 180 is 180. So we go on to quadrilateral. 4 minus 2 is 2. 2 times 180 is 360. So that's your interior sum of a quadrilateral. So let's look at this one, for example. This is a pentagon, right? 5 sides. We can find the interior sum by doing 5 minus 2 times 180. So 5 minus 2 is 3. 3 times 180 is, I want to make sure, 180 times 3 is 540. Okay, so that is how you find the interior sum. So we're going to be going back to that a lot. So interior angle sum. So let's go ahead and find the number of triangles formed. This is how they developed it, okay? So they're using the idea of a triangle, okay? And so the reason why they minus 2 is because they have 4 sides, but they can create 2 triangles. Same thing here, right? We have 6 sides, but if we take up 1 point and we don't draw a line to the 2 points that are next to them and create triangles, okay? 4 sides equals 4 triangles, okay? Same thing here, 8 sides. If we draw a line, make however many triangles we can, right? That's 6 triangles. So it's minus 2 of how many triangles you would have. So that's where they get this from. So regular polygons have equal sides and equal angles so that we can find the measure of each interior angle. So regular polygons are great because, like they said, we can find the measure of each angle by just knowing how many sides we have. So let's do that for each one of these. All right, we know we have 3 sides, and 3 minus 2 is 1, so 1 triangle, okay? So then we do 1 times 180 divided by 3 will give me each of these, since these are regular, okay? So they're all equal. So 180 divided by 3 is 60. And so that is how our interior sum of each. Same thing here, we have 4 sides, 2 triangles, so the interior sum would be 2 times 180 divided by 4. And so that would be 360 divided by 4, which would be 90, which makes sense, right? Because it's a square, 90 degrees. All right, same thing here. We have 5 sides. So then that is 3 triangles. And so we do 3 times 180 divided by 5, okay, equals 108. All right, same thing. We have 6 sides, that means 4 triangles. So we do 4 times 180 divided by 6. And so we do 180 times 4 divided by 6. And so y'all are kind of getting the formula, right? If we want to find the interior sum of a regular polygon, right, we just take however many triangles we have, which is minus 2 of how many sides, multiply it by 180, and divide it by how many sides we have every single time. Okay, and they might not always be pretty numbers like this one. This is 128.57. Okay, we'll keep going. We got 8, 6. Let's go ahead and just fill all these in. 9, 7, 10, and 8, 11, and 9, 12, and 10. Okay, and then I'll go ahead and put in my formula. So 6 times 180 divided by 8, 7 times 180 divided by 9, 10 times 180 divided by 8, or wrong way, sorry, 8 divided by 10. I was trying to do it too quick. 11, no, 9 times 180 divided by, I was in a flow and I totally messed up. 10 times 180 divided by 12, okay? And so I'm just gonna put all these in my calculator to make it quick, and that way we can move on to the next thing, because I think y'all are getting the picture. So 6 times 180 right? So these are how formulas are developed. You notice a pattern, you just keep doing it. All right, so we got all of our angles there. Okay, so we already talked about this. So this is our formula to find each interior angle of a regular polygon, and we can develop that by using our formula n minus 2 over however many sides we have, n minus 2 times 180 divided by that. So pretty easy. All right, so let's look at this regular hexagon. The interior angle sum of this regular hexagon is 6 minus 2 times 180. So 4 times 180 which equals 170 or 120, sorry, or 120, 720. Okay, and so we take that 720 and we divide it by 6 to find each interior angle sum. So that's 120. All right, so these are the types of questions you're going to see a lot of in like on your test and everything. So here we go. So we're going to find the interior sum first, okay? We do that by counting the sides. So we have 1, 2, 3, 4, 5, 6 sides. Okay, so we already did that regular hexagon. We do 6 minus 2 times 180. You always want to start there. And that equals 720. So I know all of these added together equal 720. So what I'm going to do is I'm going to do x plus 102 plus 146 plus 120 plus 124 plus 158, sorry, all equals 720. Okay, and I'm running out of room. Okay, and so we should be able to add all our like terms together. So we'll add them all up. 102 plus 146 plus 120 plus 124 plus 158. Okay, and all these equals 650. So your x plus 650 equals 720. And we'll subtract 650 on each side. So we get x is equal to 70. And that's our answer. Okay, so y'all are getting the idea, hopefully. This is how we do these problems. So again, we'll start with counting how many sides we have. 1, 2, 3, 4, 5, 6. Is that 6 again? Yep, 6. So we know. Same thing, 6 minus 2 times 180 equals 720. And then we're going to add them all up. So x plus 121 plus 96 plus 101 plus 162 plus 90. Okay, and make sure, I see a lot of people miss this angle right here just because it's just labeled as a little square. So make sure you label that, or make sure you include 90 in here. Okay. We're going to add all those up. 121 plus 96 plus 101 plus 162 plus 90 equals 570. And that equals 720. So we'll subtract 570 on either side. So x is equal to 150. All right. So now we're going to talk about exterior angle sum. So this is real easy. Every single time the exterior angle sum of any polygon, all polygons, is 360. So to find the measure of each polygon or each exterior angle for a regular polygon is just 360 divided by however many sides we have. Okay, but in this case, right, we have all these angles, but what are all the sum of these equal to? 360, so all of them. So 2x, it doesn't even matter, I don't have to count the sides or anything. I just add them all up and set them equal to 360. So combine like terms, 3x plus 89 plus 67, it's 156. Oops. That's 204. Divide by 3. X is equal to 68. All right. Same thing here. We're going to add all these up. 62. Or I want you to try this. Try it. Pause the video. Try it by yourself. And then don't be done. And then I'll go over the answer. All right. So hopefully you're done. 62 plus 35 plus 69 plus 41. Oh, I'm running out of room. Plus 58 plus 5x is all equal to 360. All right, so I'm gonna add all those up. So we get, let's see, 20. $256, so 5x plus 256 is equal to 360. Subtract by 360, and I get 95. 5x is equal to 95. X is equal to 19. Okay, so hopefully that should be pretty easy for you. On your test, I believe you'll have one of these, and then one's like the other problem. These are also kind of fun. So you're given then just one piece of information, and then you're able to fill in the rest. I want you all to try these 3 on your own. All right, hopefully you've done them. So this is 8 sides. This is octagon. Or 5 sides, 8 sides. 8 sides is octagon. The interior sum would be 8 minus 2 times 180, which, if we put that in our calculator, we get a lot, 1080. And so to find each interior angle sum, we take that number and we're going to divide it by 8. We get 135. And so the exterior angle sum is always 360. So that's what we can put right there. And then we do 360 divided by 8. Just kind of bringing it all together. All right, so that's hopefully what you got. The decagon is 10 sides. So the interior angle sum would be 10 minus 2 times 180, which is 1,440. We'll take that 1,440 and we'll divide it by 10. And so that's 144 for each interior angle. The sum is always 360, so we'll do 360 divided by 10, and that's just 36. Okay. All right, here's the challenge already. So if we know this is 60, we know that the exterior angle sum is 360. I would have to divide 360 by 60 to get however many sides we have. Okay, so 360 divided by 60 gives me 6. Okay, so now that I know how many sides I have, I can now do this problem just like I would normally do any other problem. So this is a hexagon because we have 6 sides. The interior angle sum would be 6 minus 2 times 180, which is 720. All right, and then I'll do 720 divided by 6, and that'll give me 120. All right, so hopefully that was helpful. If I went fast over anything, please pause the video, rewind it. If you get stuck on the homework or anything, feel free to reach out. All right, y'all are awesome. Hope you have a wonderful day. See you soon. Bye.